What's up, Algebra 1? Today we introduced solving literal equations. We talked in the past about solving normal equations or inequalities, compound inequalities. So we're kind of adding to our arsenal of solving skills here, because the next step once you can solve equations would be solving equations literally, or solving equations that have more than one letter in them. And that's kind of where literal comes from in this sense. It's literature, multiple letters in it. Or you're literally manipulating the equation to equal maybe a different part or a different variable. And so for this one, it says we want to solve distance equals rate times time. And we're trying to solve that for r here. So this formula may be something that you used in middle school. It's like if you travel 4 hours at 40 miles an hour, that'd be 160 miles in distance, for example. You may want to change the formula a little bit where you were solving for a different variable. Maybe you knew the distance you were going and you knew the time, you just didn't know the rate or the speed. So we're going to recognize this as multiplication, and to move that variable, let's divide. And so there's our answer. We need the distance divided by time equals r. So even if you don't know that formula or you're not familiar with how it works, we are manipulating each given formula to find a specific new equation that would match that equation, but it's been rearranged a little bit. You're solving for a different letter. So number 2, we're solving for t. And so we have to recognize that when things are against each other, p, r, t, these are all multiplying against each other. So let's divide the 2 away. And now we can figure out that t would equal I divided by pr. So I'm going to do a quick example. Let's say you did 7 times 8 times 9. That would be 504. So that's like your I, R, and T. And so if I take 504 and divide by any of these two numbers kind of multiplied together, that's going to give you that 9. Okay, now I wouldn't do that very well if I asked it to do this. So order of operations is real important here. Notice that I grouped this idea of 7 times 8 to force it to do it correctly. Or I could have said 504 divided by 7 divided by 8. Even that would have also given me 9. But using the calculator carefully to understand what you're looking at. So number 3, this is the area of a triangle formula. If you just had area equals base times height, that would be a rectangle. For example, if I had a rectangle with a base of 8 and a height of 2, the area would be 16 for that. But when you talk about triangles, you'd have to cut that in half a little bit. That would be why you have to change your formula with the 1/2 in front of it. But again, we're trying to solve for b. It says solve for b. And so we want to change the entire equation so that b is by itself. So the first thing I lock in on is this division of 2. Let's multiply by 2. So when I multiply 2 to the other side, I can just write BH. Now if you want to put the 1 here, you can, but honestly it's understood to be there already. So b and h are multiplying together. So let's divide that value away. And it looks like my answer is 2 areas divided by the height. That would be a formula if I wanted to calculate just the base of the triangle. So I'm looking at my answers, 2a over h. Let me see. So be very careful. Looks like b is very close, but those are not the same answer. So make sure that you do correctly have the order 2a divide h. All right, so this is another formula you'll do in geometry. This would be like maybe a pyramid, which I'm not a very good drawer, but maybe it's a pyramid, or maybe you're talking about a cylinder. But we're talking about the volume, like how much air is in it, or how much water is in it, how much can it hold in cubic space. So if I'm wanting to solve for h, I need to kind of do similar as I did the last time. Let's multiply 3 over to the other side. 3v equals BH. And again, this 1 here is understood. I mean, you can write it there, but it's not necessary. Now again, I'm trying to get h by itself, so always pay close attention to what you are solving for, because that can kind of help me understand what I'm moving around. So it looks like h would equal 3v divided by large capital B. So 3v in this one. Okay. So really watch out for the order in which you are dividing. That is super important. All right, so P in this particular formula stands for perimeter. For example, if I had a triangle, that's not a real triangle. Sorry, I took geometry seriously as a teacher, so I don't want to make sure I make possible triangles here. So 2 plus 3 would be 5, so 3 is 4. All right, so this could be a potential triangle that exists in the real world. And so, for example, my perimeter, if I added all of these up, all 3 of those sides, that would be 9. So I have a perimeter of 9. But what if I wanted to change the formula where I knew the perimeter, but I wanted to solve for one specific side that I didn't know? And so what I want to do is look for what I'm solving for. It wants me to solve for C. So that means I really need to lock in on moving A, and I need to also lock in on moving B. So tell me which one you think is correct for this one, and we'll check your work in class tomorrow. Let's look at, this is another one. This is actually a perimeter of a rectangle. If you have a rectangle, you have 2 opposite sides that are the same in length. So maybe these are both 2, and these are both 8. And so if I wanted to calculate the perimeter, it's like I have 2 8s, that'd be 16, plus 2 2s, that'd be 4. And so I have a perimeter of 20 in this rectangle I made up. But maybe I want to change the formula to calculate a particular aspect of it, maybe just the width. So this is one that we did in class today. We also did one similar in the library, if I took you to the library. So I want to start by moving that 2L to the other side. P minus 2L equals 2W. And then again, if you're trying to get W by itself, lock in on anything that's on its side. Recognize what it currently is doing. It's currently multiplying, so I want to divide that away. And we really want to look for the same answer here. Looks like C again, P minus 2L over 2. That is how we can solve just for W. So this is actually an interest formula problem. You have your principal, and then you have like your principal times the rate and the time in which it was invested. So you may see this one in a future finance class or something like that. But for this one, it says we want to solve for T. Now it's similar to one of the other ones, that IPR problem at the very top. But we have this P that's by itself at first, so I think the first thing I'm considering doing is moving that value over to the other side. Now I want you to consider what would I need to do from here to move PR away from T. And then I'll let you answer that one on your own. So that one's one step away. Try one more step in order to figure out what that one should be. All right, number 8. Number 8 is a really funky looking formula, and it's because it comes from a funky looking picture. Let me see if I can find the picture that I am wanting to draw. Let's see, it's this one. This is what we call a trapezoid. So a trapezoid has 2 different bases. You have a large base and then a little tiny base up here. And really, the reason why we have 2 bases is because really there's 2 different ways you could look at it. It just depends on the way that it's oriented. But we also have the height from the top to the bottom. And so the A stands for area. What is the area of the trapezoid? So I am wanting to solve for this little b. I want to calculate what would that upper base length be if I knew the area and I knew the height and I knew that bottom base. what would that little b have to do, or have to equal? So I want to start again. Anytime I have a dividing value, I consider changing that as long as there's not constants that are being added and subtracted in between them. So that would be 2a. I don't want to put 1h. I think I'll just put h, and then I have big B plus little b. Now keep in mind which one we are targeting. We're trying to get that little b that's in that parenthesis. So some students probably would consider multiplying h here. Honestly, I think what would be best is to divide it away. When you move it away, you are going to make the next step a little simpler, and you're making the whole problem a little shorter. So I've got one more step here. One more step. Tell me, what would you do to get b by itself, and then look at your answer choices to pick which one you think would be correct for solving for b. Okay. And then one more formula. When we talk about Fahrenheit to Celsius, these are two different ways that we calculate temperature. It depends on where you live, honestly. A lot of places like in the United States, we are using Fahrenheit, but a lot of other places use Celsius. So let's see, I'm just going to show you that a lot of countries use Celsius. For example, we are the only country, for the most part, that uses Fahrenheit. Most of the other countries in the world, if you travel there and you ask the temperature, you may be real surprised. It sounds like colder than you think it would be. So for example, let's say I thought my today's temperature, which is about 58 degrees, 58 degrees is about 14 degrees in Celsius, okay? You saw a minute ago, 32 degrees would be 0. So there's a little formula that we use to change these back and forth so that if you're traveling or if you just need to change the unit of your temperature to the other unit, then you can use this formula. So this is currently a formula for Fahrenheit. We want to change this formula to Celsius. So we're solving for C. So let's start off by subtracting 32. Let's move 32 to the other side. And now we have 9/5 of C. So there's several ways you can talk about moving 9 and C. It's all based on what they're currently doing. For example, I'm currently dividing by 5, so I could multiply both sides by 5. 9 is being multiplied, so I think I will divide it. Now, what I'm really doing here is I am using what's called a reciprocal. And if I want to move 9/5, I could just multiply both sides by 5/9. But notice that I used grouping on that side. I didn't just put it in front of f. I really wanted f minus 32 to all be multiplied by 5/9, and that's how you can ultimately get the correct answer. All right, so I've got a few minutes to talk about a few of these questions. These are mostly review, so I'm leaving the ones that we've been doing several times this week for you to do, but I'm going to spend a few minutes talking about a few of these at the end. So again, solving literal equations. Solving for A, I want A by itself, so I think if I just divide C over, A would equal D plus R divided by C. And there's your answer. Okay. I want to make sure everybody can read that. It's kind of hard to read. A equals D plus R over C. All right, another one I want to talk about is 9. If you're solving for X, trying to get X by itself, really I only need to move K. And K seems to be multiplying, so I want to divide it. Now, the best way to write this division on the other side is to just put it in the denominator with those other values. So I think that would be my best answer. X equals W divided by V, Y, and K. All right, so why don't you try these on your own, and we'll check your work in class to see how well you do. Hope you're doing well. Hope you're healthy right now, and we'll see you tomorrow. Peace.